Welcome back. In this lecture, we're going to learn about another very popular architectural pattern, which is called Microservices Architecture. We will start with the motivation for using this architectural pattern by comparing it to the monolithic three-tier architecture pattern, which we learned in a previous lecture. And later, we will talk about the advantages, best practices, and challenges that come with this architectural pattern. So what is microservices architecture and when should we use it? In the lecture about the multi-tier architectural pattern, we learned about the three-tier architecture, which we also refer to as a monolithic architecture, because all the business logic was concentrated in one single service in the application tier. As we mentioned earlier, the monolithic three-tier architecture is the perfect choice for small teams that manage a fairly small and not too complex codebase. However, as the size and complexity of our codebase grow, it becomes extremely difficult to troubleshoot and add new features to it, as well as build, test, and even load the entire codebase in our IDE. On the organizational scalability dimension, we also start having problems, because the more engineers we add to the team, the more code merge conflicts we get, and our meetings become larger, longer, and less productive. Once we start seeing those problems, we need to start switching gears and consider migrating our architecture towards microservices. So what is microservices architecture and how does it solve all the problems that we just mentioned? In contrast to the monolithic three-tier architecture, microservices architecture organizes our business logic as a collection of loosely coupled and independently deployed services. Each service is owned by a small team and has a narrow scope of responsibility. This architectural style offers us a lot of advantages. The narrow scope of responsibility in each microservice makes the code base a lot smaller than what we had in the monolithic architecture. This provides us with a wide range of benefits. With a small code base, development just becomes a lot easier and faster. For example, now the code base loads instantaneously in our IDE. Also, building and testing the code becomes much easier and faster, simply because there are far fewer things to build and test. Additionally, troubleshooting or adding new features also becomes much easier, because the code itself is much easier to reason about. And new developers who join the team can become fully productive a lot faster. In terms of performance and scalability, we also get a lot of benefits from breaking the monolithic application into microservices. Each instance of our microservice becomes a lot less CPU intensive and consumes far less memory, so it can run much smoother on commodity hardware. And we can scale each such service horizontally by adding more instances of fairly low-end computers. On the organizational scalability, we also get a lot of advantages. Since each service can be independently developed, maintained, and deployed by a separate small team, we can get very high throughput from the entire organization as a whole. On top of that, each team is completely autonomous to decide what programming languages, frameworks, and technologies they want to use, and what kind of release schedule or process they want to follow. Finally, if all those benefits aren't enough, we also get better security in a form of fault isolation. Which means that if we have an issue in one of our services, or one of our services starts crashing, it's a lot easier for us to isolate and mitigate the problem than if we had an issue in our single monolithic application. Now, it's hard not to get excited about this style of architecture, and unfortunately, a lot of organizations jump too quickly to microservices without considering two major factors. The first factor is while theoretically we can achieve all those benefits from migrating to microservices, we don't get all of them for free out of the box, just by splitting our monolithic codebase into an arbitrary collection of services. So, in order for us to get the full benefit of this architecture, there are a few rules of thumb and best practices that we need to follow. And if we don't follow them, we can easily fall into our nemesis, the big ball of mud. The second factor to consider is that microservices do come with a fair amount of overhead and challenges, which have to be taken into consideration before migrating to this architectural style. So first of all, in order for us to achieve full organizational decoupling, so that each team can operate independently, we need to make sure that the services are logically separated in a way that every change in the system can happen only in one service, so it wouldn't involve multiple teams. Otherwise, if every single change requires meeting with another team, coordinating the development and the release of the new feature, then we don't gain much from the migration to microservices. To achieve this, there are a few best practices that we need to follow. The first best practice is the single responsibility principle, which means that each service needs to be responsible for only one business capability, domain, resource, or action. For example, if we have an online dating service, we can have the following microservices separated by their business capability and subdomains. The user profile service is responsible for the business object that relates to the user's profile and every way that the user can interact with it. The image service takes care of the storage, resizing, and presentation of the profile-related images. The matching service is responsible for matching different users based on the rules that we define, as well as the preferences that the users define in their profiles. And finally, the billing service is responsible for everything related to charging the users money for the services they're consuming. So now, when the user wants to update their profile or see someone else's profile, they would simply be directed to the user profile service. If they want to upload images, they can be directed to the image service, and when they want to get suggestions for potential partners, they can contact the matching service, which would in turn talk to the user profile service to figure out which profiles would be a good fit for the current user. And of course, whenever the user wants to purchase additional services, they can be directed to the billing service, which in turn may contact the user profile service to unlock certain features for that particular user. Let's take another example from the e-commerce space, and this time we will separate the microservices by the actions related to the way users interact with our system, as well as the entities we have in our system. On the action side, we have the product search service, which given a search query from the user, performs a search and returns a personalized view of the relevant products for that particular user. But to find those products, it talks to the product inventory service, which encapsulates the products entity. Another action-oriented microservice we have is the checkout service. So when the user goes to checkout, they will see what they have in the cart and also see the amount of tax they need to pay, which we accomplish by talking to another action-oriented microservice, the tax calculator. This service will calculate the tax based on the product's price, category, and the user's location. And finally, when the user confirms the purchase, the checkout service will orchestrate the entire transaction by talking to the billing service, shipping service, and the product inventory service, which are all entity-oriented services. Additionally, we can also break the API gateway that used to be a monolithic service into multiple microservices. So depending on the type of devices or clients, we can have separate API gateway services that are more specialized and therefore more lightweight. Now, the second best practice to make sure that there is no coupling between different services is to have a separate database for each service. Otherwise, if two services share a single database, then every single schema or document structure change will require careful coordination between multiple teams. On the other hand, if each service has its own database, then the database essentially becomes an implementation detail of each service, and it can be easily updated or replaced completely transparently to the rest of the system. It's important to note that when we split the original monolithic database and provide each service with its own database, the data has to be split in such a way that each microservice can be completely independent and fully capable of doing its work while minimizing the need to call other services. Of course, some data duplication is expected and is the overhead that we need to accept when we move to this type of architecture. So, in conclusion, following all those best practices will definitely set us in the right direction for success using this architectural style. However, I want to reiterate that microservices architecture provides all those benefits despite the complexity and overhead only when we reach a certain complexity and organizational scale. And it's always best to start with the simple monolithic approach first, and only when that architecture stops working for us, we should consider microservices. In this lecture, we'll learn about a very popular and useful architectural pattern and style, which is called Microservices Architecture. We talked about all the benefits that this architectural style provides us with, especially when we reach a point of complexity and scale that the monolithic three-tier architecture stops being a good fit for us. All those benefits result in higher organizational and operational scalability, better performance, faster development, better security, and so on. And finally, we talked about a few considerations and best practices that we need to follow to achieve all those benefits when we use microservices. I will see you all in the next lecture.